Monday, Careers Day. Let's see, pretty tight. All right, so good morning and welcome to a very important week. This week we add data persistence to our API. So do you remember back in the day when we drew this? This was a conversation about async and await, but it's also talking about a client that connects to a server asynchronously. And then you have our API that connects to a database also asynchronously. But then this database is not like a database and that's it. No, it's a server. It's another server, right? So we have a server running the client, a server that could potentially be running the API, and a server running the database. And then that server will have, this is our data store, will have one or more of those databases. Okay, so for the question about what it looks like, it was SQLite was the requirement. Optionally, you do PostgreSQL and pgadmin. I'll show you both today, so we'll cover that for sure. Okay, so let's do a super quick go through training kit. I mean, you're gonna go through this material if you didn't do on Friday, but what do we talk about this week? Starting today, we do an introduction to relational databases. Then we'll talk about this thing called structured query language, SQL. People tend to pronounce it SQL. And then we'll see how to write a few SQL queries. Think about if you communicating through this language instead of JavaScript. You're going to communicate to the database with the database server and manipulate the data using SQL. And then we're going to set up something called Connect.js. It's a JavaScript library that will let our API connect to the database. And we're going to perform the CRUD operations that we did using SQL, only this time from JavaScript. That's the menu for today. And of course, the rest of the week, we're just going to continue practicing the same thing, interacting with the database from our JavaScript code. Okay, so there is a career related to databases, administration, development, and all that. It's a totally different path from being a web developer. So this week is about, if I am a web developer, someone else takes care of the database stuff. If I am a web developer, how can I interact with an existing database? And of course, we get a very shallow introduction of, okay, if at some point I need to kind of come up with a design for a database, what would that look like? What would be the workflow for that? And what do I need to think about? But it's not by any means a deep introduction to databases. That's not what it's about, okay? So introduction to relational databases. We probably want to think about this first from, okay, what is a database? And then why is it relational? So what is a database or something that we use for data persistence? Well, a database, let's not show it. If you were trying to explain to me what a database is, but not any database, but the ones that we use computers for, like the databases that we write or use on a computer. What would that look like in that thread? How would you explain it to me? What do you think a database is? Information storage. Yes. 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 Oh, come on, team. Don't, no, nah. Your words. Yes. So all of that is information storage, is a collection of data that can be related or unrelated for sure, a way to store data and retrieve it, record storage, tables or of resources. Yes, 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 and yes. Data categories is yeah, some data, but a database. Okay, so a database is a storage or record or collection of data. Yep. What makes it a database and not just a pile of data is the second part that says data that you can easily, it is optimized or organized for easy retrieval later. So it's not like you take a big jar and you throw coins of every kind in there and then you're like, I need 20 quarters and you have to sift through that. No, it's organized like accountants organize finances. That's the way that it's organized. Super, super tightly organized so that you can easily find the information that you need later. Okay, that's a database. What makes it relational though? Sounds like because it's just relationship between them. Yeah, that's what it sounds like, but not really. Um, so if you ever get that question, it's not about relationships. That's not the relational part. The relational part is because of the way data is stored. Data is stored in something that looks like this. This is what do you call that? What do you call that? That thing like columns and rows. The table, spreadsheet. Yeah. Exactly. So it is stored in a spreadsheet-like format where you have rows and columns, okay? The mathematical term for that happens to be relation. So relational databases is because when they were created originally, they were based on the relational model on mathematics, like sets and stuff. So uh, the way that they saw it as a mathematicians, they were like, okay, I'm going to start data in a relation instead of in a table. But over time, we're going to call that table, okay? They're just tables. So let's say that I wanted to store some account information in here. I'm assuming that this is my whole database. This is not only a, a sheet, it's more like a spread book, right? It's a whole book of, I could have different sheets and then each sheet could represent something. But I'm gonna use this single sheet and I'm gonna create a few tables in here. I'm gonna say, I wanna save information about accounts. And then the next question would be, what information do I want to save over accounts? Maybe I want to have an ID and maybe the name of the person on the account name, like pick a name, right? Uh, maybe I want to have other information. Maybe I want to have an email as a contact, as a way to contact that account. And if we start adding data here, let's say 1, 2, and then no, don't worry, this is gonna get you somewhere. Oh, no, no. My spreadsheet foo, it's lacking it is. And then we're gonna have like account 1, account 2, and I think I could take those two and just do that. Boom, there you go. Email 1, I guess 1, email 2, and then just do that. Boom. And now I'm gonna grab this thing and make it look more like a table, like so. And yeah, this is definitely not needed. I'm just doing it because yeah, feels better now. There you go. So what we just did, my friends, is we manually created the stuff that gets created in a database whenever we need to save data. So the way that we store data on a relational database is by using something that looks like this. It's got some rows for each piece of data, and each one of those separate pieces of information that we store, they have different names, but we could say if this is a table has rows, and each row is going to have columns, and that will work. Everybody will understand you. So the data inside of a relational database is going to be stored in tables. The cool thing is that if this was, let's say, my game database, I'm gonna call it game DB, I could have accounts for my game, and each one of those records is gonna go into this accounts table, but I could have another table. Maybe this is one of those RPG games where you have characters, and those characters have different classes. So let's say that an account could have more than one character. So I'm going to have another table for characters that also is going to have an ID, and it needs to know the account that it belongs to. So I'm going to call this account ID, or you could even say account. And then what information do you want to save about the character? Maybe the name of the character, and maybe other things. But for now, we're going to keep it like that, super simple. So again, we can start adding data here, and you're like, yeah, this is not databases, Luis. I know. Don't worry, we'll get there. So we're gonna merge that, copy the format, boom, and now we have again another table in the same database. So that's what it looks like. I needed to store some data about the accounts. What do I need? A table. Let me go create a table for that, and then I start adding data. Well, I need information about characters. Well, let me go and create another table for the characters. But there's a relationship between them, you know, because the character has to belong to an account. So yeah, you save information about the account. Just to make it clear, I'm gonna do what I normally do, which is I put ID at the end there, so that you know that what we store here is, so instead of me duplicating, start thinking about this. We talk about data modeling on day 4, but from now, I want you to have this mental model. What you're doing is, I need to store information about, whoops, a table about that. And then when there are relationships like this, like an account could have a few characters, or a character always is created within the context of an account, then do I copy the account name and the account email and the account ID here? No. Instead, we rely on this value over here, the ID value. We're going to assume always that the ID is going to be unique for each record on the accounts. So if I want to say that this character belongs to that account, I could just say, what is the ID of that account? 1. Let's say that this account number 1 starts having 2 characters. Okay. Set of characters here, and then this is character 1, character 2, because each character is going to have a unique name, of course, like so. And maybe this character belongs to account number 3, this to account number 4, this to account number 2 again, this to account number 1, 3, 10, 9, 3, 3, 4, okay? So that's it. That's a database right there. It's a database that could save information about accounts and the characters on those accounts. Questions there? Of course, the tables on the database we're going to use is not about accounts and characters, but this is context. All right, no questions, so everybody gets this. Now, how do you create all of that? We'll talk about that after first we learn how to manipulate data. So go back here. So that's what a relational database is. It's just a container of data where you can have multiple tables on that container of data, and the information is super organized so that you can easily find it when you need it, okay? Now, what about this structured query language thing? I think I have it here. SQL, what is structured query language? It is a just like JavaScript, it is a language, but this language was created originally, and that's the main use today, to communicate with databases. Now, do you communicate directly with the database? No, you communicate with the database server, okay? So a database server handles way more than just the data. It handles security. So normally, even though we're going to use, there are different types of databases. One way that you can classify them is there are server databases and there are databases that are based on a file, like Microsoft Access. It's an example of a database. There is an open LibreOffice something also that is a file-based database. You have a single file, and that file contains the database and other information. SQLite or SQLite, I think it's SQLite. SQLite is another type of database that is a file-based database. You don't need to have a separate server running just to use a database. So we're going to use this is the database used on all browsers. It's the database used on all iOS devices. So every time you store anything in an iOS, like if you're playing a game or look at your contact list, all of that information on your cell phones, your iOS devices, your Android devices, your Microsoft devices, all of that information and all of the information on browsers and a lot of the games that you play and things that you use, devices that you use, that store data somehow, like your microwave, if you have a microwave that have macros and stuff, all of those devices use potentially something similar to SQLite. But in reality, most devices and embedded databases will be using SQLite. So it's a really, really, really widely used database, like a lot of installations and uses. It is self-contained, it is small, super fast. Of course, they say full feature, but it's a somewhat, kind of full feature. There are some things missing, but it's really good for learning. So that's the main database we're going to be using. The other type, if the database that requires that you have a separate installation of a separate server somewhere so that you can connect to it, okay? Right. So let me show you an example of what it looks like if I had a database that had some data and I want to get some data out. So please, if you want to follow along, please open this in your browser, this website. And you will have something that looks like this. Maybe you have some other stuff on the screen, but this is the bare minimum of that. There is this button here that says Restore Database. If we click that and click OK, what this does is it takes the database that you start with, you can modify it, and it will restore it to the original database. So if you start deleting things or adding things and you want to go back and restore it, because you're going to get a copy of a file, this is also using a SQLite database in your browser. Okay. So what do you find on this database? This database has customers. It's got 91. Another name for row is a record. So if I ever say a row or a record, I'm talking about the same thing. It's just a row on that table. So it's got 91 records, 8 categories, and 10 employees. And then you have like 196 orders, and each order has, the details of the order, how many of each thing you ordered. So it's got 518 of those. You have products, shippers, and suppliers. A pretty simple e-commerce type database. So if you come to me and you say, I would like to see in JavaScript, if we want to have a comment, we can do this, right? There's also multi-line comments, but for a single line comment, it would be like that. On SQL, which is another language, we're going to do 2 dashes like this. So if I want to see, can I get a list of all products? Okay. How can I quickly do that using a relational database? Well, I could write a SQL statement for that says select all of the columns from the products database. And this is the name that the table has right here, the products database. And get used to having a semicolon here. This is how you mark the ending. This tool that we're using is a browser application. Someone wrote this. It's not necessarily what you will find on every database engine, but it kind of does things for you. Like, it doesn't require the semicolon, but you're gonna see me type the semicolon, get used to it. And then we're gonna run it by clicking this button here. There you go. So on the bottom section here, we got the list. Notice how this looks exactly like a table. Because it is a table. And there they are, 77 records, because we have 77 products on the database. Now, what would be the query that you would write if you go to that page and I want to see a list of all employees? What would be the query that you would write for that? Yeah, select star from employees. Exactly, very nice. So just changing the table name, super simple. I'm gonna grab this, this query that I'm writing here. And in the guided project for today, I'm creating a new file down here and I'm calling this file queries. That's equal so that I get some coloring for the code, right? Formatting. What this file is going to have is a list of all the queries that we write in class. So if you want to go back and review the queries that we wrote, you can see it on this file. Is SQL case sensitive? Good question. Parts of it are. Databases can be configured in different ways. So the question is this case sensitive? The actual keywords are not. In fact, I'm going to write everything lowercase so that I don't have to be switching from lowercase to uppercase. Now, what do I mean by some parts of it are? When you're doing comparisons of strings or days or things like that, you can configure the database to be case sensitive for those. This database, as a matter of fact, this database that we're using for the sample is configured that way. Most databases aren't. I think this is the only case that I've seen where they configure it to be case sensitive, maybe a JavaScript thing. But most databases are configured so that you can do comparisons using casing sensitive comparisons. So I want to say that most of the time it's just casing sensitive. For the naming and all of that's just for comparisons. That's it. Like if you want to compare, name versus name, they have to match. The casing of those two strings have to match when you're comparing them. But other than that, all of this is case insensitive. Okay? People from the was first created languages like COBOL and SQL. The people writing back then used, I don't know why really, because when I came into the scene there, it was already a thing. All of the COBOL code that we wrote used uppercase for the keywords and stuff. A lot of the SQL code that you wrote used uppercase for the keywords too. But it was not a requirement, it's just people did it that way and it kind of stuck around. I guess it's easier to separate keywords from the rest. But that was back in the day where the editors that you had were a single color. They were probably amber or greenish. Or like light bluish, but now you have color coding on the editors and it's not needed anymore. All right. So the other question that I have is, what is the difference between that and this? Please make a note of this. Grab a pen, because you will forget it. Sometimes you have objects on the database that have names that are invalid. There are some rules for naming your objects. Like you shouldn't start a name with something like this, right? It's not gonna work. It works in JavaScript, but not on SQL. Also, what if you bring some data from a text file or something, you insert it into a table, and it ends up being something like uh, products list. Now you have a problem where you have a space in the name. What if you have a table that instead of being called orders is called order? Well, you don't know yet, but this is a keyword. What if you have a table of locations and you want to have something that says from, a from table? Then that would be like, oh, this is a keyword from, duplicate a keyword, and it would give you an error. So square brackets is a way for you to use invalid names for objects. If you find yourself using brackets, rename the thing. Okay, so using brackets is a sign of maybe you need to rename some objects on your database, but that's the use for it. It is so that you can use invalid names for database objects. All right, so questions about interacting with data. Remember, this is not, we're not going to learn about creating databases, creating tables, none of that. It is, a table is already there, you're just interacting with the data. The part of the SQL language that has to do with manipulating data is called data manipulation language, but still it's just, you could think of it as like kind of a sub part of the SQL language. All of this is SQL, is the structured query language. The part that we are using now, which is I am writing queries to ask questions of my data or to retrieve data from the database, is the part of SQL called data query language, DQL. So if you ever see that, like, I'm gonna write some DQL for that. That's what it means. It's just write some select statements, basically. Okay. So what else? What else can I do with query? Oof, so much stuff. For instance, and remember, we're gonna do all 4 operations today. So I'm gonna quickly show you a couple of the select statements, and then tomorrow you learn more, and then you learn more, and then you learn more. But things that I can do is look at the information that I have down here. I could pick only the columns that I care about. Maybe you have a drop-down list that only needs the ID and the name of the product. You don't need all of the other stuff. So you could definitely say select, but instead of having a star means give me all of the columns. You could pick the columns that you want. Maybe I only care about the product ID and separated by comma, the product name. And that's it. From where? From my products table. Boom. And if we run that, notice that we had 6 columns. Now we only get back 2 columns. Can you run multiple commands at a time? Not in this tool. But you will see that most databases will provide, there are quite a few of them out there, but there are graphical user interface applications that you use to connect to databases. Most vendors, for instance, MySQL, they build the database server, but they also build a graphical user interface. I think it's called MySQL Workbench, so that you can connect to their database and write queries. Those tools will let you run more than one at the same time. Most database management systems also have, you could think of them as kind of a runtime environment like Node, where you can actually write a SQL script. So it's like a JavaScript file, only written in SQL, that will execute a whole bunch of commands in order, like a SQL program. So SQL scripts like that can also have a whole bunch of multiple commands. Not this tool, not this web application here, doesn't let you do that. What anybody remembers what I said about semicolons? Let me see where we are. Let's see. There's a thread there. Okay, exactly that. You finish when you, if you were to have multiple statements, the way that you tell the tool that you're using to connect to a database, I am done with this statement, move to the next, is by using a semicolon. This tool though doesn't need it, so you can leave it out, but I will always place it there as a way to show you, yes, you should end your SQL statements, because you could have this in 2 lines or 3 or 4 or 5. So the way that you tell it, yeah, I'm not done yet on this line, continue reading until you find a semicolon. So get into the habit of adding it even if you don't need it on this tool. Good job, Jonathan. So there is a question, is a SQL script a stored procedure? No. A SQL script is just a script that normally you save on a file. Stored procedure, we're not gonna get into that because again, that's database stuff, but a stored procedure is a program that you store not in a file, not in a script, but on the database. So you can actually write a program inside of the database engine itself and give it a name. So it's more like a, and there's a difference, right? But because you can also have functions in some databases, you can have stored procedures and user-defined functions. They have different names, but you could think of it as a kind of a module inside of the database, like a module that we have here that could have a whole bunch of functions and calls in there and all that. So it's like a little program, but it's not on a file like a script. It's more of an inside of the database itself. Pretty powerful. Okay, so back to this. We can pick the columns that we want by listing them separated by commas. You don't have to follow. Notice, first of all, let's pick this SQL statement to make sure that we keep a record, right? Notice that we had the star here, and we had the ID. The ID, I keep forgetting that you don't execute here with Command Enter. ID and name, you don't have to do that. Maybe I want to have the name, the price, and then the ID. You could definitely reorder the columns here, and this is going to be for the results. That's not going to change the table at all. It's just to organize the results. Maybe we want to have the product name and the price, and then the unit, maybe, right? And now you have product name, price, and unit, not necessarily in the order that they are in the table originally. And there you go. Cool. Questions there? Okay. What if I want to filter? I don't want to see all the data from the database. I want to see only part of the data from the database. How can we do that? Let's do a quick select star from customers. Remember. And we have the city. So what if I want to see only from customers from the UK? So all customers from the UK. And here's where the string comparison that we talked about comes in place now. Okay, so it is from customers. Let's say that I want all the data, but the way that you filter is you tell it where, and then you do the comparison operation here. This comparison operation behaves like any operation that you do in any programming language. You can group it using parentheses. You have different types of operators. Some are unique to SQL, but all of the mathematical operators that you expect are there. Like there are a whole bunch of operators that you can use, like greater than, equal to and greater than, equal, all of that is there. So if I want to check for the country being the UK, I could say where the country is equal, not double equals, equal to, and then single quotes. If you're trying to follow along, you're going to miss this explanation here. For dates and strings, use single quotes, even though this tool will let you use double quotes. That's not the standard. The standard is for dates and strings, you wrap them in single quotes. Okay. So let's do UK. If we do UK, this database is configured to use case-sensitive comparisons. So that will break, not break, but it will fail. You wouldn't get anything back because the database doesn't have lowercase UK stored. Okay. This may be different. Again, all databases, but this one that I've used always have this set to case insensitive. Okay. But the tool does it this way. What can we do? Here we go. So that looks, remember, this sample database has case-sensitive comparisons. Let's say string comparisons. So we need to use the same casing. Copy that, drop it here. Questions there? The database administrator should tell you what the settings are for the database, or you should ask them. There are ways, but the thing is that each database server, there are quite a few of them, will have a different way of figuring that out by yourself. And you may not even have access to see it. So your best bet is you ask. Such good questions. It's amazing. Very nice. All right. So in JavaScript, you can do this. You could say and you could say or. Okay. In this, though, in SQL, you can actually use the word and. And you can also use the word or. So given that knowledge that you can use and or, I want you to list the customers from the UK, Berlin, and Berlin. I don't know if it's Berlin or Berlin. In Spanish, it would be Berlin. So I want to see a list of all the customers from the UK and from Berlin. That's your exercise. Go and drop that link. You can use parentheses to group conditions, yes. And it works exactly the same as JavaScript. Inner parentheses are resolved first and then the outer ones. Yes. Ooh, very nice. So let's grab the first one there because it seems to be correct. Try that and run it. Very nice. And I told you part of this exercise, I told you or. I didn't tell you that you should look for the city instead of the country for Berlin. Okay. So what about, and this is a tricky one, from the UK and USA? What about that? How is that different from the one that we just did? And why is it tricky? Very nice. Everybody got it right. Nice. So I'm going to copy this other select. All right, have a couple of answers there. Yes, yes. All right, so I'm gonna drop two there, two of those. So the first one is this. Why is it different? Because you could feel tempted to say where country equals UK or USA. That wouldn't work. You actually have to list the full expression again. So country equals UK or country equals USA. This is great. This works, but there's another one there that introduces a brand new keyword. The keyword is, or clause called in. So we're going to use that as a way to introduce it. You can actually pass it a list and say, hey, um, can I get my customers where the country is in this range right here? And the country is included in one of these values, separated by commas. So let's also copy that one. Using the in clause. That's an operator, kind of. Okay, questions? That is about it for getting data out of the database today. There are more things that we can do. Okay, we'll continue to do that, but I want to keep it simple. What can we use for excluding? We can use the not operator. If I say not, there are quite a few operators. So what you're going to do, of course, in your own time is you're going to go and check SQL operators, and you're going to see comparison operators, mathematical operators, and all of the other operators. An exclusion is a thing, is a tricky thing, because if I had something like, let me show you, let me drop this here just as an example, because it's a great question. This would be excluding those from the UK and USA using the not keyword. But if you have something like this that says select all from, let's say, products, where the price is greater than, I don't know, 5, how do you exclude those? You change the operator the same way that you do in JavaScript. So you say, I don't want the other stuff. Well, you could say greater than, less than or equal to 4 or 4.99 if it's money. Okay. So that's how you exclude. You just filter for something else. Different operators. SQL it was designed originally to read like English, and it just makes so much sense. Like, it's been around for like the 60s, and it's virtually the core of the language is unchanged. What most database vendors have done is they have added some special things to work with their products, but the SQL language per se, the standard, has been virtually unchanged. So good, so good. All right, so let's take 5 minutes, and then when we come back, we're gonna complete the other 3 operations. Is how can I add data, remove it, and update it using SQL. So see you in 5 minutes. Bye. All right. Thanks for all those good questions. So again, there's a lot more that we can continue to do with select. There are a couple of things. So one thing that is really useful is, what if I do get the list of all my clients? Let's say list of all customers like that. But I would like to see this. I would like to see the country first. So I'm going to say country. And then I want to see the city. Postal code maybe not as important, but then I want to see the rest of the information, right? So I could leave that star in there, about, as a matter of fact, and just the country and the city are going to be, see, at the beginning, and then the city, and then all of the other data is just going to be there, right, after that. So it's basically saying the rest. It's like the rest operator, the ellipsis operator. So country, city, but again, this is not as useful. What would make this, what do you think would make this more useful? What do you think? What would make it a little more useful? Say that I want to organize and plan my cells based on the regions that I have customers on. Yeah, alphabetical. Yeah, if the list was sorted. So how can we do some sorting? Yes. Uh, no repeats is going to be tricky because you want to see every customer and you want to know about their country. But we will cover a way to do something about that, but not today. Not today. Today we go super, super simple. So how can I sort it? Well, let's say that I wanted to sort this by, let's write a name here. Sort it by the country, then by the city, and maybe then by the name, the customer name. Okay, great. So separate this in another line to start kind of seeing the separation there and see that white space should be used freely to organize your queries. So over here, I'm going to say sort by. No, not really. It's called order by. It's not about sorting. It's about ordering, right? So I'm going to say order by the country first, comma, then the city, comma, the customer name. And how do I control? Let's say that I wanted to see maybe the country in descending orders. Super simple. I could say descending or the ESC. By default, it's going to be alphabetically ordered ascendingly. So, but you can control it by having this DESC out there. And you could also organize the city descent and the customer name. So let's do ascending, which is normally what we do. Run the SQL, and here we go. Now you see that Argentina is right at the top. Then organize it, Austria, G and S, Belgium, B and C, and all of our, now this is a little more useful. So let's copy this query, capture it in our samples, semicolon at the end, and here we go. Questions there? Yeah, default ascending for everything. It's going to be the default. Numbers, strings, dates. Okay. So that would be how you sort things. But what about this? What if I want to see a list of the top 5 products based on the price? So that would be the top 5 or the 5 cheaper products. Let's do it that way. So 5 cheaper products. I'm gonna do now, turn this into a navigator, driver navigator thing. I'm gonna be driving. Can someone navigate for me? Help me get started with this and I'll finish it. What can I do? Someone talk to me, tell me, navigate. You can unmute. But what do I get to start? How do I get started? I'll complete it, don't worry.
Select everything from products first.
Okay.
By price of the products first.
Then run that to see the table columns.
Yeah, you have to see the table.
All right.
Let's do price. Sort
Where
by
price?
Limit 5.
Yeah, but
Sort by price.
okay. So
And then limit to 5.
order by price.
Yeah.
Okay, and then pick only 5, right?
Yes.
Limit.
Yeah. And this is one of the parts of the SQL language that you could see that you're gonna find that is different depending on the database you're using. You learn it because you tend to use 1 or 2 databases only in your companies. You learn it, but most open source databases will use the keyword limit. If you ever see an example that says something like top 5, they're basically doing the same thing. Only that top in those databases is the same as limit. But not all products support that. I think limit is more of the standard. So instead, we're gonna use limit. It doesn't work here. Limit 5. That's it. So we got all the information that we want from the products. We're gonna order that by price to make sure that the cheapest is at the top, and then we're gonna limit it, saying only give me the first 5 that you find. And there you go. Those are the cheapest one. And if you want to find the Apple products, you do the same thing, only that you sort it by descending order. So why would the cheapest be at the top? Because I'm organizing it by the price ascending. So smaller numbers are going to be at the top. If I want to see the most expensive, just organize it descending to see the bigger price at the top. All right. It's a tricky one. That's a hard query until you learn how to use limit. Right, that's it. Let's see how to add data. Adding data. Let's go and insert 3333355555. Oof, I don't know what that means. So let's go and insert some data. Let's look at the shippers table. You have the shipper name on this is super simple, so we're going to use that. So we are going to add a new shipper, a new shipping company. For that, we're going to use insert. Insert can be written in a couple of ways. I'm going to show you the one that is preferred. So insert into, and then you say the table. In this case, it's going to be shippers. The shippers table. And then you provide a list of the values that you're going to, or a list of the columns that you're going to provide values for. And then you specify the values in parentheses, like so. There is a way to insert data without specifying the column names. Don't use it because most databases will have some column that they generate. Like in this database we're using, the sample database will auto-generate the shipper ID. So that's tricky. You don't want to pass it because you may conflict with one of these generated. So the version that you tend to use when doing insert is you pass as a collection of column names, and they don't have to be in the same order. Maybe I want to pass the font first. So I could say font and then shipper name, like so. These have to match column names on the table, right? And then after you have that, you pass the values. And the trick here is the values must follow the same order of the identified columns at the top. So if I have phone first, I should have, and this is going to be a string because this phone is stored as a string. Okay, single quotes. So maybe this is going to be, I don't know, 212 555 1212. That would be the phone, and then comma, and then we pass it a name. Okay, great, perfect. Run it, and this is what we get back. We get how many records was the database able to insert. Okay, so we are inserting one. Why do we get a number? Well, because you can potentially insert more than one at the same time. So if that is the case, let's say that I wanted to also insert another company, and now we have Lambda shipping. So I'm gonna have another one that is LS shipping, and copy this set of values, and then comma, and the next one is going to be it's gotta have another number, like 4, and then this other one here is gonna be code shipping. Okay. So you pass another set of values separated by commas in parentheses 2. Run that, and now this tells me that it inserted 2. So we should have 3 new records in there. Let's copy that and capture in our sample, of course. Here we go. So this would be Lambda. That's the one that we wrote without the second. So inserting multiple. Another example. Let's go see it. Let's do a select star from shipping purse. There we go. Ooh, there's an error there. You see it? What would be the error? It's a spelling error. Yeah, I forgot the B in Lambda. What do we need to do for that? How can I fix that?
Update it.
Yeah, I need to find a way to update that. So that's the next thing. How can I how can I update this to fix that, right? So let's go fix it. And we have another problem, which is this is actually 1211, but we accidentally did 1212. So we need to actually update 2 of the 3 columns. We could do that. We could update 1, 2, or 3. So for that, we're going to use the update, right? So fix the errors. Okay, update what? Shippers. What do I want to do? Well, I want to set a new value for something. I want to set the shipper name to be Lambda shipping. Comma, I want to fix the phone. Since I am at it, I might as well just fix them both. And this is going to be $12.11. Boom, done. Now, what do you think would happen if I did that? Yeah, it doesn't know. Okay, so you want to update those values? Great, I'm just going to do that for the whole database. Oof, very dangerous. So this is the first gotcha with databases. whenever you are performing a destructive operation, something that will modify data on the database, like maybe an update or a delete, triple check, please. But especially for the update and the delete, make sure that you have a where clause there, okay? Unfortunately, I cannot do it on this tool because it doesn't support it, but let me show you what I normally do. I would have something like this. I would have this be a comment. I'll show you how to do that with another tool later. Maybe not today, but you're just gonna see me do it. But I do this, select star from, and then the table that I'm using is shippers, just to make sure, right? So it would probably look like this, just to make sure that I have this where the shipper ID is the easiest way of doing this because we already have it, equal to 4. Again, unfortunately, if you try to do that, you can do the second step for this. Okay? And the second step is most tools, well, maybe they fixed it. I don't know, let's try it. Most tools will let you grab, highlight a portion of a statement and then run just that portion. So if this was supported by the tool, this is normally how I do my updates. So whenever I'm manipulating data on a database, you see what I'm doing here? That I'm keeping this script. I normally do that. I normally do, right? And I keep the history of all the statements. Because normally when you're doing this directly on the database, just so you know, my first Microsoft certification was actually dealing with databases back in 2000 maybe-ish, around there. So I have done a lot of like data munging and stuff using SQL. So normally you open a query like that and you want to keep a history of all the stuff that you did, just in case, right? So having this ability of selecting a piece of the code and just run that, it's really useful. Let's try it just in case. I don't know. You see, I'm selecting the update from the update on, right? It should have updated, but it's not. Still wrong because it doesn't support that feature. It's just running the whole thing. So in this case, what we would need to do is comment down manually up there and then uncomment down here to have the same effect. And then we run it. Oh, look. No, we have a problem somewhere. Semicolon over here. Here we go. Boom. So affected one row. So the question would be, how can I affect more than one? Well, you're going to affect as many records as your query covers. So your where is gonna, it could be for one record, it could be for a whole bunch of records, and they all get updated. Can it be reversed if you update them all accidentally? So many people have been fired over forgetting a where statement or having the wrong where statement. So many people have been fired for not testing their code, right? Before executing it or before submitting that to someone. So you should always test your code. I mean, how could you possibly write anything like a SQL statement or an endpoint and not test it? So especially when dealing with data, you definitely want to test that. But also, yes, also please test. Test your endpoints. Don't copy and paste endpoints without and turn them in without testing them. Just in case. All right. So going back here, this is normally what I would do. I would write a select statement first to guarantee to look and make sure that I'm targeting the right data, and then run my updates or my deletes. Cool. So I'm gonna keep this as a sample of an update statement. There you go. Cool. And you could have this on a separate line if it's easier to read what's going on. Remember to test the where condition with a select first. Okay. I don't know if I'm making my point clear here. There you go. What is the best way to implement redundancy on a database in case something catastrophic happens in production? You hire a database administrator. That is really, really good. Or you pay for a service that has redundancy built in. Now, let me tell you something though. Redundancy will not solve this problem. This is a story. I just don't remember the name of the company. I'm gonna take 2 minutes to tell you a story, but this is just a story, right? There are different ways of approaching what you really want is called something called disaster recovery. Okay, one of these strategies that you could use is you could have something called replication, and replication is you have some kind of main database, and then you could have other databases kind of listening or subscribing to the changes and replicating those changes. There was a company that assumed that having replication was as good as having backups of the data. And a backup of a database is kind of a picture of how the data is at a point in time. But here's the thing, it's a copy of the data. So if you have 5 million records, if you have a database that is 20 gigabytes in size, and you do a full backup of that, you're basically copying those 20 gigabytes in size. So it's like a snapshot in time. Those are not cheap. And if you're getting a lot of transactions, you can't really recover all of the transactions. There is no way that you could save them to more than one place and keep different copies over time. It's just going to be insane, the sizing. Again, even for backups, you have different types. You could have a full backup, but you could have something called an incremental backup. And then you could go down that rabbit hole, and there are super set of many strategies for dealing with backups. But replication is not backups. It's not disaster recovery. You know why? You know how they had to close their company? Because they made a mistake on the main database. And they're like, let's, recover from the replicas. But here's the thing. All changes were being replicated to the replicas. So the replicas only had a copy of the same thing. So replication or replicas of your database are really, really good for disaster recovery when you have a database in New York and then you have a database in, Europe. And the idea here is if you're on the eastern side of the country, you may know that during the summertime when it's really, really hot, you are going to have blackouts. Why is that? I don't know, the power plants, they overheat or whatever. One time in New York in the 90s, I was without electricity for like a whole afternoon. And it happens. So what happens if your product is down for minutes? Well, if you're Amazon, you lose millions upon millions of dollars. So you can't really be out. And it could not be up. Maybe you say, I have power supplies. Yeah, what about the connections? What about the networks? Can you guarantee that everybody involved in providing a service is going to have all the backups in time and ready in case there is a blackout? You can't, right? You can guarantee your data center, but you cannot guarantee the rest of the stuff on the web. So what do? Well, you replicate to different geographic new locations around the world so that you could have something to go. Like if you're 4 hours without electricity, what do? Well, you take one of the replicas, turn it into the main, and start serving customers from Europe. So when it comes to data, be very, very careful because it's really, really, really hard to recover from a problem on the data. Cool. Even if you have a service. Think about the number of transactions a database on a company like eBay or Amazon generates per minute and the size of those databases. You cannot, on every record that is added to the database, go and make a copy. It's just unsustainable. So there is always going to be some data loss. So what do you normally do? Well, if I know that I'm gonna be running a lot of queries against my database, because I wanna maybe adjust some data, maybe I renaming some things, I'm moving data around. What would you normally do is you make a backup of the database, run it somewhere as a testing database, and then you run all your queries against that. And you keep a record of them, and those turn into a file that is a SQL script. And it's basically a history of all the steps that you need to go from where the database data is at one point to where you want to get. And then you test it. And then you check that everything is really, and you check like 20 times to make sure that everything is working fine. And then you delete that database and you make another backup of how the production data is now. And you run that SQL and you check. And then you delete that database. And then you make another backup of the production data. And you test that script again against the copy. And you check to make sure that everything. And you think really hard. Really hard. Before you run that. And then you make a backup, run the query, and then you have a backup, and then you go and check in the production to make sure that everything is good. But dealing with data is very stressful. I can tell you that right now. Drop table name fixes yeah. Yep. All right, that's it. I'm gonna stop there. Really good questions, but this is not a database thing. Just know that you have to be very careful when you're doing updates and deletes. Speaking of delete, how can you delete? Let's delete. Right, again, you always want to run your SQL statement. So how can I delete? Well, delete from shippers, where the shipper ID is for. If we run that, ow. Let's try it again. Nothing was affected now. Why is that? Well, we already deleted the one with number 4, so I could run it as many times as I want. Now, nothing's gonna happen. It doesn't exist. So you get 0 back, basically. Okay. So that's this would not fix errors. This is deleting a record or set of record. Okay. So you always check to make sure that you have the right records. And then when you're sure, then you check again. And then you call someone to come check. And then you call your mom. Yes, Mom, can you take a look at this data before I delete it? Right? I may be exaggerating. Probably your mom doesn't know about databases, so you probably call your grandma instead. She's been around for a while. She probably knows. She knows everything. But the point is, be very careful with data, and this is how you delete. Questions? Okay, so we're gonna do a 5-minute introduction to a query builder, and then we take a break, and then we come back and write some JavaScript that does something similar to what we have done here. Okay. What is a query builder? Connects. And yes, it's connects, like the connects. If you go look at the old commercial of the connects things that you connect together, is based on that. Look at the symbol, the logo. So connects. Connects is what is called a query builder. Let me show you. I don't have my iPad here today, so I'm gonna have to reuse something from an old. Here we go. So it's gonna reuse this for today. So you have some application running on a web server through the network, connects to your API, and then your API can communicate with the database server, right? And the database can have multiple databases, the blue database, the red, the smaller blue, and then this other database. And it's got a list of the users, and this is a server that has security and all that, right? Or you can have SQLite, which is simply a file. So the API can connect and talk to SQLite directly. It's file-based, so you don't need to have a separate server. Now, you miss out on a lot of features like security. It's a single user database. You no longer have to keep a record of, you don't need a username, you don't need a password. As long as you can open that file and write to it, you're good to go, okay? Now, some other big names on the database world are things like Oracle, probably the fastest or best database in the world. And you have Postgres, MySQL, Microsoft SQL Server. MySQL was acquired by, I mean, it was created as an open source project, and it belonged to Sun Microsystem that was acquired by Oracle. So now Oracle owns those two. So a lot of people flocked out of there into something called MariaDB, which is a fork of it. So MariaDB is basically a fork of MySQL that is fully open source and fully like free. And then you have MySQL that is free and open source, but it's owned by a corporate that it's not as open source friendly, I guess. So those are some names of servers that you can install to manage your databases, and each server could have multiple databases. Each database can have multiple tables in it, and up we go. Now, this portion right here doesn't tell you the whole story, because your API doesn't really talk SQL. Your API talks a language that is not SQL, maybe JavaScript in our case. So what do? Well, this is what we do. Inside of our API now, we're going to write our JavaScript. Now, this JavaScript is going to be handed down to something called a query builder. In our case, it's going to be Connects. So basically, we're not writing SQL code anymore directly. I mean, you could. There are ways for you to use. Sometimes you need to write SQL, but we're not going to cover any of that, because for the basic operations that we're dealing with here, you could just write JavaScript code using Connects. And then Connects is going to do the translation. It's going to take, and the power of this is, let me show you, so you have an idea of how powerful this is. If we go in here into the schema builder, we're going to talk about that probably on Wednesday. When we look at the create table, just to have an idea how nice this is. Look at the create table, right? This is how you write it in JavaScript. You're basically calling methods on objects. So you have this connects, schema, create table is the method, right? So you have this connects object that has a schema property, and then it's got a create table property method in it. You call that and pass it a couple of arguments, and it generates, here's the output, generates this code right here. Create tables users, and then look, the ID is a serial primary key and the other stuff. And the created at is something called a timestamp Z. So it translates JavaScript into your SQL. This is the SQL destined for Postgres. But look at this query right here. And I'm going to change that to be Microsoft SQL Server, which is another database server. You will see that that primary key called ID is going to turn into an identity column. Look at that. Boom. Now we wrote the same query, but now this is destined for Microsoft SQL Server. But the part up here, still the same. What does that mean for you as an API developer? That means that if you write, and if you stick to using connects methods instead of writing raw SQL, you don't have to know the difference between Microsoft SQL Server, Postgres, and even if I change this, I'm going to change, see, this is identity now. I'm going to change this thing to be Oracle. And, oh, they use the same. No, I'm going to use another one. I'm going to use MySQL. MySQL is going to create that in a different way. Look, it's going to be on-sign, not null, auto increment, primary key. So you have seen that 3 out of the 4 databases, 3 have a different way of creating that primary key. Out of 4, 3 have a different way that you would have to remember. So the power of a query builder is it gives you this abstraction, this translation layer between knowing the intricacies of each database management system, or just know how to use Connects, and that's it. It takes care of that for you. Pretty cool, right? So we're going to write code that will, there are differences, okay? There will be places where the differences are so big that Connects cannot normalize for that, but the code that we're going to write for basic CRUD operations is going to be optimized for SQLite and Postgres. So you can switch between the two without any problems. And basically between all of them, I think, all of the databases supported. This tool supports the main ones, as you can see right there, including Amazon Redshift, which is something on their web. How does that work? Look at that. This is, again, going back to that identity one and all that stuff. And if you look at the created at, it's still a timestamp Z here. Let's see if they do something different somewhere else. Look at that. If I change it to SQLite 3, now this is a datetime instead of a timestamp. So it's not having to remember all that. It's great. So what would you tell me if I ask you, why is something like connects useful to you? So how does the connects know which type of database are you trying to write to? Yes, this is a great question, because that goes exactly into my next thing. Very nice. Very nice. Jessica, very nice. Yeah, you can change database systems, fewer syntax differences to remember. Yeah, makes your life easier. Very nice. Okay, so how does it know? Well, let's go back to our diagram here, because I diagram and tells us. Okay, so connects translates between SQL and JavaScript. Great, but who does the, okay, now I have to target that towards a particular database. It doesn't do it alone. You have to provide, in addition to connects, you have to provide a database driver. Here it is. So you have JavaScript, connects, and a database driver. And there is another difference between databases, and the difference is databases communicate differently over the network. I think all databases have their own special network protocol, so they're not necessarily using HTTP. From your client to the database, the network is different between them. So the driver takes care of not only telling connects, hey, here's the way that you write particular syntax, but also it knows how to talk to the database over the network. So that's delegated to the driver, to the database driver. So to use a relational database from our node applications, we're going to use connects and a database driver depending on the database we want to target. Cool. So connects is our query builder because it can build queries, SQL queries based on JavaScript methods. And then we need a driver. And for SQLite 3, we're going to use SQLite 3. That's an NPM package. And for Postgres, we're going to use one called PG. Eventually, if everybody gets Postgres installed. So why do we pronounce the K before the N? Because of that. It's based on this. And if you look at some videos, don't look at it now, but create a building toys, connects. Remember that connects, basic fun? So if you go look at the videos for that, listen how they pronounce it. And since the whole library is inspired by the be able to connect to different databases and to different pieces from the library, this is why we pronounce it. Trivia there. All right, let's go back. Let's go back to the code. Come on, we want to write some code. What do you say? Let's take 5 minutes and then we come back and write the code. What do you think? Easy? Yeah, let's take 5 minutes and then we'll come back. Hey, welcome back. For the content this week, there's a catch-22. Is that there are so many things interconnected that need to be in place for databases to work. But if you only concentrate on that plumbing code, then you kind of don't see results. So we're gonna give you some of that stuff already configured in the project so that you can concentrate on, let me get my data. Let me get some data quickly, right? So I'm gonna show you, I'm gonna open this folder, but don't worry about it until the end of the week, okay? There is this file in here, and inside of this file, I'm doing some magical configuration, okay? So this file already does some of the setup for us. It's using connects. It's reading this connects file. Let me open it for you on the right so they have an idea. So again, I'm just doing this to show you some of the stuff that we have in there already in place, not for you to go ahead and try to understand it today, not today, okay? And then I am reading from this configuration file, this development object, and passing it to connects. So remember, two parts. We have connects and we have a driver, but it's not only that, right? Connects also needs to know what's the name of the database, what's the username if you have a database that requires one, what is the password, where can I find the server if you're using a server, or in the case of SQLite, super simple, it's just like, where's the file with the database? That's all you need to tell it. And some other things, but basically to connect is like, I need to find the file. So that configuration happens on an object that you pass to connects. And as you can see right here, this is how it knows. That right there, my friends, is the database driver. Oh, I answered a question on Slack as a reaction, but there's a question that says, how do I know which database I'm targeting? Well, depends on what you're using in your project. It's not only like, it's not what you use in your company, because most companies will have more than one type of database, because there are types of databases and they are geared, they're better for some things, but not as good for others. So most companies will have multiple types of databases. And even of the same type, let's say that you have relational databases, which is a type of database. You may have a server that is for legacy code that has been around for a while. And maybe then you decided to move out of, let's say, MySQL into Postgres, and then you may have another Postgres server. So you have now two relational databases. But for testing and development purposes, maybe everybody uses SQLite. So now you have three possible targets of relational databases alone, not to mention the other types of databases that you can have. So depends on the project. So whatever that project is using, that's the driver that you're gonna need. Hopefully no one else got kicked out of Zoom. Maybe it's a glitch on your side, hopefully only. We all here? I mean, I have 42 participants right now. Is that a good number? Hopefully, yes. All right. So again, this configuration object is something that you learn later, but just know that the project that we're using already knows how to find and talk to the database. That's my point. So we're going to concentrate on performing CRUD operations against that existing database. What does the data in that database looks like? We're going to be writing blog posts, right? And it's going to have a title and some contents. That's basically it. A single table, super simple. We need title and contents, and those are strings. One is a string limited to 1024 in size, and the other one is a whole bunch of text. Think of a blog post, it's just unlimited text. As long as you have space or memory, you're good to go. And they should not be empty, okay? So title and contents, and they need to have a value. That's about it, okay? Hey, why am I like on all the way over there? There you go. So how do we do this? Let's go look at our API server file. This is using the post router. Okay, let's see what we have in there. Oh, also, we want to look at the package.json. Look, we are using Postgres and SQLite 3, but they're not installed. So the first step is we need SQL server driver for a database, and also you need connects. So npm I connects space SQLite 3. So that's your first command today. We want to make sure that we got our libraries. So go install them. Let me know, please. Can't do anything unless we install those two. All right. If you look at your package.json, you should have connects with this version and also SQLite 3 version 5. That would be good. That's success. Great. Everybody's there. Now, let's go look at our router. And today, we're going to start by writing all of our database code inside of here. Let's go run the server. npm run server. Oh, look at that. We're having a problem here that says, command not found. Why am I failing at this? I'm just going to do an npmi again, just in case something is kind of weird there. Okay, let's look at this just to make sure. npm run server non-mon index. Well, I don't know. Maybe it wasn't installed. npm run server. Yeah, that was it. I cloned it and didn't do npm install. All right, so it's on port 4000. If we look at the server though, there's an endpoint here that we can test our server. So let's go check it out just to make sure. Do the same thing, please. I'm gonna go to localhost 4000. There you go. Now I know that my API server is running. Okay. Now on the post router though, I would like to go to /API/posts. So that's our goal. /API/posts. If we do that, probably gonna crash. Look at that. Why is that? Because there's no code there. All right, there's no code. All right, so we're hitting this endpoint over here. Let's write some code in there. And what I want to do is I want to return a list of posts from the database. Not return, respond with a list of posts. You remember that db config file that I showed you that has a way to connect to the database and all that? I am requiring this file over here and I'm calling it db. So for me, this file represents a connection to my database. So let's say db is the connection to the database. Okay, great. So there are more than one way of executing, sometimes 2, 3, 4 different ways of executing the same code using connects. I wish it wasn't so, but hey, flavors, okay? So let's go and get familiar with the documentation and pick one of them to do our first endpoint with the select. If you go to connects, all of the documentation is a single page. So you can scroll up and down the page, but you do have sections here on the left. We are working with the query building section, and you'll see, don't worry about all of those things. You will need some in your career, some you won't, but they're there, okay? And the command that we use, if we were writing this, a collection, there's a table called posts on this database. I could write this, select star from posts. And that will give me the list of posts, right? Turns out that I could say, hey, database, I would like to select star from posts. Now, this is an asynchronous operation. So what do I need to do if I want to get the actual data? What goes there? What's their name? Yeah, not that then. He never hangs out alone. They're not the homies. The homies are up here. It's not the amigas, that's for middleware. It's the bros, then and catch. It could be the sisters too. Should we call it the sisters? All right, so then and catch, right? They always hang out together because you need to handle the error. So if there is an error, what do? Well, different things, but for now, we're just gonna console log it, that error. But also we need to produce a response, rest that status. I don't know, I ran into a problem on my side. It's not you, it's me, dear client. So we're gonna do 500 and send back a message. Oh, we could call it error, error that message to have an idea of what happened. We can see it on the console, but we also get the error message on the terminal. And then here, if we are successful, we're gonna get a collection of posts out of the database. Rest that status, 200, and then we're gonna send back JSON and get into the habit from now on of wrapping the data somewhere in an object, because that object may contain and will contain other information. So the data is going to be the posts. You could call it whatever you want. Only if you're using Access, it's going to feel weird because it's going to be like that, then, response, that data. So yeah, there's that. So maybe we call it posts. Excellent. So look how similar to an actual select statement this is. There is a shortcut though, when you don't have to do select and from. I'll show you that on the updates and the deletes and stuff. But know that you could pretty much translate a select statement from SQL into connects pretty easily. Let's try it out. Let's see if I can get some data back. All right, let's see. And we have data. Look at that. Woohoo! Inside of an object that has a data property, and here's our collection. Your turn, go. All right, looks like everyone is good to go. So let's go write a post so that we have our way to create data. Cool. Again, if you go to the documentation and you click on the select statement, you'll see that there's more than one way of doing this, writing this. Look at that, usage with TypeScript now. Oh, great. Oof. Oof. Anyway, so there are, remember that you could use, oh, we haven't done that, but we'll use later, so you'll see what it is. Again, there's a whole bunch of code in there. I'm gonna show you a shortcut too, so don't worry, we'll get there. See that star there? If I wanted only let's say the ID and the name, you could just pass ID and name there. Separate it, so ID, comma, let's say name, like that, separated by a comma. You could select more than one column. For now, we're doing star. Okay. So a post. What do we need on the post? First, we need the data, right? So const, the post is going to be equal to right.body. Okay, now that we have the data, we want to save it to the database. So we're going to say db. What is the command that we use for adding data to the database? Insert. All right, so edb, I want to do an insert. Okay. Now the problem is the database is going to be like, okay, but which table? So there is a shortcut to tell the database, I want to work with this table. So you can say db as a function and pass it the name of the table. I could say posts. So basically, this is a shortcut for db.from. Which means that I could have done this. I could say db posts over here, and then just do that then, and it would have worked. So I'm gonna keep. Okay. So working with the pose, I want to do an insert. What do I want to insert in there? What do you think should go there if you were writing this? The post, yeah, the data right there. I'm going to insert this post into the database. Now, this is an asynchronous operation, so the bros go, or their sisters go in there. Okay, boom, there we go, boom. I'm going to borrow some code from up here. And then what we get back, you remember when we inserted a record, what did we get back out of the database? Yeah, we got the number of rows affected. When you do an update and when you do a delete, that's how it works. But in the case of the insert, what you get back is an object and it's got a single property in it. So I'm going to show you that. This is SQLite, so there's I'm gonna complete this in a minute. So we're gonna say, I'm gonna get back, actually it's not an object, it's actually an array. So I'm gonna call it IDs. That's what you get back. Since the database is saving that record, it's going to get a unique ID. So you get back an array of IDs, but it's got one value in there. So let me show you what it looks like. There's that status. The status code for creation is 201, of course. So we're not going to do 200, but 201 here. And then the inserted value is going to be that collection of IDs that we got. Okay. I'm going to save that. And we need title and contents, right? So duplicate this, make it a post. Go to the body, select raw, JSON. We need title, a post, and the contents. What happens if I don't pass the what happens if I do that? Look at this. We get an error. Here's the message for that error. It's telling me, you try to do an insert into the post, passing a content at a title, and here are the values. But the table posts has no column named content. Tell me that's not a really good error message. That is a great error message. This is telling me exactly what is going on. It's because it's called contents. So if we pass it a contents, and then we hit that, this is what we get. Okay, we get an array, and it's got the ID of the record that was just inserted last. What do I mean by that? It means that if you insert 100 records, you get one ID back. The last ID. You always get the last ID wrapped into an array. Cool? Keep that in mind. Now, if we look at our console, other than this error, because, you know, that error, this is the first error because we console logged it, but there is nothing else in there. So let me show you something. Well, today you're not gonna see it today because we're using Postgres, but well, yes, you're gonna see it now because you're using SQLite. So I'm gonna show you on the console here. I'm gonna make a small change to the code, and you always now, because you want to support both Postgres and SQLite with your code, when you do an insert, you're gonna pass either a returning here with a value there that says ID. Maybe you want to do that, or you could pass it as a second argument here, ID. I'm gonna use the shortcut like so. You know what? I think it's clear if we use the returning. So let's just use the returning. I normally have done the other part. Maybe this is easier. So if we save that though, I want you to look at the terminal here once I insert. I'm going to insert another one that says connects is not a toy. Send that. Okay, now that got the ID 14. And look at this message right here. See that? Make sure that I place that on the README or on the code right here. Don't be afraid. That is okay. It will go away when using Postgres. Okay, so when you see this warning in the console, forget about it. Not a problem, not an error either. It's just telling you exactly what it's telling you. It's telling you, you know, SQLite doesn't need that because SQLite will always return the ID, always, whether you have it or not. You saw me write the code and test it without the returning. We got the ID. Then when we added this, we still got the ID. So, right? So what are we missing? We're missing a delete and an update. Great, let's go do those. And for the insert though, I'm gonna give you this sample code. So you have it there, but you're still gonna get my C file. There you go. That's basically what it does. You say, hey, post, I wanna insert this post and I wanna get back the ID. Do not exclude this line if you plan to support Postgres. Should always be there. And remember that what you get back is a collection of IDs. You can get creative and go and get the record after that, but later. Okay. All right. So let's do the delete because it's simple. The update is also simple. Let's do the update first. So I'm gonna say, hey, I need some changes. So const changes. Those are going to be on the rec.body. I also need the ID. So the ID is gonna be equal to rec.params.id. And now we're gonna go to the database and say, I wanna work with the posts. And whenever you're doing an update, what is the one thing that you should never forget? Because it could cost you your job. The where clause. Very nice. Okay. The where clause. So since we don't want to forget that, we're going to have it be first here. So we're going to say where. And here we go back to the documentation to show you that the where is a beast. Because you could have object syntax, you could have key value syntax, you could have functions in it. You have a group chain, you could, and then it talks about operators. Like, it's a beast, but it's not as hard as you think. So we're gonna pick one of those and stick to that until we need another. So the simplest version of that is, if you're doing a where statement, it would probably look like this. Okay, where the ID is equal to, let's say, you know, whatever the ID is up there, whatever that ID is. This can be written in two ways. If you're using equal, the equals operator, you can omit that operator. So you could use object syntax or strings, or use a whole bunch of other stuff, but here's the simplest way of doing that. Pass an object with the ID equals to the ID. Since this is a single value, the same name, you could actually, let's just do this, so make it different. I'm gonna call this post ID. So you know what's going on, post ID. But if it's the same name, you can just pass it in there. Okay, so as part of it, that will give you only that record. That would be kind of the same as a select. And then what do I want to do? Well, I want to update it. And I want to pass it the changes. The cool thing is Visual Studio Code is really friendly. So it tells you, hey, give me the data. This is all the other stuff. So update and then the changes. That catch. What do I get back? I'm going to get back a count. That's what we get back this time. Same with the delete. And if you want to do a photo for like, I don't know if I updated something. Well, the count, remember that when we delete it, we got a count of 1. And then when we hit it again, we got 0 as the count. So if the count is 0, that means there was no record to update. So we could say if count, if I have a value there, I'm going to do this. Else, very important to have that else there, res.status, photo 4, and then some kind of message there that says not found. Okay, so you know what it is. Res.status, this is going to be a 200. Everything was great. And then a message, updated successfully. Like that. Okay, let's close this. So that's the update, basically, right? You could also write this where, I'm gonna give you another way of writing it, where it looks a lot like the other SQL. You could say where the ID, and you could have the operator, but if it's equal, you can omit it, but I'm gonna leave it there so you see it like so. Another way. Okay, there you go. Oh, it would be post ID, sorry. Post ID, here we go. I don't wanna get that wrong. So with the post, where this is true, I want to update it, giving it the following changes. Questions there. This is magical, okay? Because if you have two, if I only want to update, let's go and give it a test. Let's take number 14 is called connects. I'm gonna change this to connects.js. So let's duplicate this over here and say this is going to be a put now. It's gonna be for number 14. And the body, if you pass it both, it will use both. But if you pass it only one, say connects.js instead of connects, it's magical. It's gonna look at, oh, the only thing that you wanna update is the title, great. And it will only update the title and leave everything else alone, which is great. So we hit send, yep, updated successfully. We go check out our posts. I don't know if we're getting all of them here, though. Yeah, there you go. So this is changed to be connects.js. I knew this code was correct, but you still test your code using Postman or any other HTTP client. Never write an endpoint and not test it. That would be insane. Please. You want sanity in your life when it comes to writing code. You want to make sure your code works. All right, let's go back into the delete. Delete is super simple. So we're gonna kind of copy this. Kinda. We don't need the changes though. So I'm gonna say this is the ID, and then I'm gonna go into into my database and say, I want to target this ID. Let's delete the number 13 or something. And again, the where is the same, but instead of updating, instead, what I want to do is delete. So there is a del, D-E-L for delete. So dot delete. And then you're going to get a count, and you can do the same thing. And this is going to be removed successfully. So this is the big change right here. Delete instead of update. Let's try it out. We have a number 13 here. We're going to remove this number 13. So it should jump from 12 to 14. Duplicate this tab, make this a delete now, and delete number 13. Removed successfully. So you say, let me go see. Hit send, and 2, 11, 12, 14. There you go. All done. Questions there? All right. That's it for today. I'm going to post this code, give you this code in about a minute. I use it as an example to work on the project in the afternoon. The names of some things may change. The data is going to be different, so make sure you read the README. See you on Slack. Thank you for sticking around.